morning to my dear students. Welcome again in this series of lectures on group theory. Today I am going to deliver my second lecture in group theory. I know you have all gone through my previous lecture in which we have discussed about the definition of symmetry elements and symmetry operations as well as various types of symmetry operations along with suitable examples. In today's lecture, I am going to discuss about all the symmetry elements and operations present in these 5 molecules. These include water, ammonia, xenophore, that is caretaker, a tetrahedral molecule and an octahedral molecule. Let's start with the first molecule, that is water, which is having a bent geometry or V-shaped geometry. In water molecule, it possesses 3 symmetry operations in addition to identity. As we have already discussed, identity symmetry element is present in each and every molecule and it means doing nothing. The rest 3 symmetry operations in water molecule are C2, sigma V1 and sigma V2. C2 is a symmetry axis which passes through, it is an imaginary axis that passes through the center of oxygen atom and rotate the whole molecule by an angle of 180 degree, which results in indistinguishable configuration. Hence, it is a symmetry operation. The next 2 symmetry operations in water molecule are the planes, plane of reflection. The first plane of reflection passes through the center of oxygen molecule and reflect these 2 hydrogen atoms. After this symmetry operation, these 2 hydrogen atoms substitute their position. In the next symmetry operation, which is again a reflection plane, but this plane passes through the center of the plane of the molecule. Thus, it includes all the 3 atoms, 1 oxygen and 2 hydrogens. After this symmetry operation, there is no change in the position of any atom in water molecule. But again, if we imagine that half part of the atom consists of black portion and a half of white portion, then these black and white portions will substitute each other. Let us again discuss these symmetry operations using ball and stick model of water molecule. Well, this is the ball and stick model of water molecule. This yellow represents oxygen and these 2 white represents hydrogen. First one, C2. This is an axis, an imaginary axis that passes through the center of oxygen and it rotates the water molecule by an angle of 180 degree. Second one, plane. This plane again passes through the center of oxygen, substitute these 2 hydrogen atoms. And the last one, sigma V2, it passes through the center of whole water molecule, means this plane is parallel to the plane of the molecule. Thus, it does one plane. Okay. So the symmetry operations or symmetry elements which are present in ammonia molecule, these are identity 2C3. These 2C3 are C31 rotation by an angle of 120 and C32 rotation by an angle of 240, and 3 sigma V. One sigma V passes through A hydrogen, second through B hydrogen, and the third through C hydrogen. Next molecule is xenon F4, which has a square planar geometry. Now, again, the first symmetry operation or first symmetry element is identity, and next one is the C4. This C4 axis is perpendicular to the plane of the molecule, means this shape. And again, as the n value is 4, so rotation is by an angle of 360 divided by 4 is equal to 90 degree. Fine. So there is C41 rotation by an angle of 90. C42 means rotation by an angle of 180, which can also be designated as C2. So there is a presence of C2 as well as C4, but again the principal axis is C4 because here n has maximum value. In addition to these C2, there are many other C2 in xenon F4 or square planar molecule, but the difference is that this C2, this axis of rotation is perpendicular to the plane of the molecule, whereas these 4 C2 are in the plane of the molecule. These involve the plane of the molecule. So this C2 passes through xenon and 2 fluorine bonds. Again, rotation by an angle of 180 degree. As a result, these 2 fluorine will not change their positions, whereas these 2 fluorine will substitute. Similarly, next C2 passes through xenon and these 2 fluorine, and there are another C2 that bisects these initial C2. So hence there are 4 C2 and this one another C2. These are all the rotation axis present in xenon F4 molecule. In addition to rotation axis, there are reflection planes. Now in this xenon 4, all the 3 reflection planes are present. These reflection planes are sigma V, sigma D and sigma H. Now the principal axis in case of xenon 4 is C4, which is perpendicular to the plane of the molecule. So the plane that is parallel to the plane of the molecule, that reflection plane is designated as sigma H, in which any of the atom will not change its position. All the atoms will remain at their own positions. Parallel to the plane of the molecule, there are 2 another sigma that are perpendicular to the plane of molecule, and these include sigma B that passes through xenon and involve 2 fluorine atoms. One is this one, another one is this one. And there are 2 sigma D that bisects 2 sigma V's. So hence, in xenon F4, these all are the symmetry operations. First one is identity, which means doing nothing. Second is C4. Here there are 2 C4. One is rotation by an angle of 90 degree and another by 270 degree. And this C4 and next C2, these are the same axis, and this axis is perpendicular to the plane of the molecule, whereas 2C2 dash and 2C2 double dash, these axes are in the plane of the molecule. Next is the I. In I symmetry operations, all the fluorine atoms will substitute their positions, means the fluorine which is present on plus X, after symmetry operation it will be present on minus X's. Similarly, plus Y onto minus Y. Next, S4. S4 is improper axis of rotation, which is a combination of 2 symmetry operations, that is C4 followed by sigma H. C4 is the same, that is the axis which is perpendicular to the plane of the molecule, then after that followed by reflection plane which is parallel to the plane of the molecule. Next is sigma H, again a plane parallel to the plane of molecule. 2 sigma V that are perpendicular to the plane of molecule, and this plane passes through 1 xenon and 2 fluorine atoms. 2 sigma D, again plane perpendicular to the plane of molecule that is perpendicular to this axis and cut the molecule into half. The behind portion will be seen in front and the front portion will be seen in back. Again, next up the sigma D. Well, in case of methane molecule, the sigma D, the plane includes one carbon and two hydrogens. This way. So one carbon and these two hydrogens will not change their positions, while other two hydrogens will change their position, will